All right, so let's move into the next topic. We are talking about taking the derivatives of exponential functions who have a base of e. Got it? There's a lot of exponential functions out there with different bases, but in this section, we're only going to be talking about those that have a base of e. So, a couple of theorems to go over first. Let's look at the first one. It says the derivative of the function f, which is given by f of x equals e to the x, is. So, interesting. The derivative of the function is just the function. Another way of stating it is, if you take the derivative with respect to x of e to the x, you get e to the x again. You get the exact same thing back again. That's not changing. So that's kind of actually really nice. The derivative of e to the x is just itself. Well, yay for that. Now, we have a second derivative that kind of goes off that extended power rule that we did in a different lecture. So let's look at this particular theorem. The derivative of e to some power is the product of e to that power and the derivative of the power. For example, the derivative of e to the power of f of x, as we learned from the first theorem, is first of all just going to be e to the f of x. It's going to be itself again. But remember that power rule says now you've got to multiply it by the derivative of the power. So that's what we're doing here. The derivative of e to some function is going to be e to that function multiplied by the derivative of the function. Cool? Or another way of writing it is the derivative of e to the u is e to the u itself times the derivative of u with respect to x. And you're like, well, why isn't that up here? You know, in actuality up here, if I take this second theorem and apply it to the derivative of e to the x, I would get e to the x, and then I would actually be taking the derivative with respect to x of just x. Well, help me out. What's the derivative of x? Yeah, just 1, which is why we just get e to the x, which is why the first theorem is written as it is. The derivative of e to the x is just e to the x. Because if you take the derivative of the power x, you're just going to get a 1 there, so it's not really changing anything. With me? Okay, so hang in there. I got some examples for us so we can apply our theorems. Be right back. So let's look at the first example. They've given us g of x, and they're asking us to take the derivative. You're like, where are the directions? I'm verbally telling you the directions. They're asking us to take the derivative. So we need to take the derivative of g of x. Now, in this particular case, g of x is an exponential function, right? So we had two theorems just a few minutes ago, and you're like, well, which one do I use? Here's going to be my recommendation. Always keep in mind that the derivative of an exponential function with a base e is always itself. And you always need to multiply it by the derivative of the power. So if you always keep that process in mind, you will never go, which theorem do I use? Got it? Okay. Well, we have this e to the 2x, and we are multiplying it by the derivative of 2x. So what's the derivative of 2x? Good, just 2. Which means the derivative of this particular function is going to be 2e to the 2x. With me? Awesome. Let's look at number 2. Again, asking us to take the derivative. So, this particular problem is an exponential function with a base e. So when I take the derivative of an exponential function with a base e, I get itself. But then you're going to have to multiply it by what? That's right, the derivative of the exponent. Good? Okay. Now, briefly, the 3 here, even though it's being multiplied by the e, it's just a constant, so it really doesn't do anything, if you recall from previous lectures on derivatives. So we're okay here. So help me out. I'm going to have 3e to the 5x, and now I'm multiplying it by the derivative of 5x. What is that? Good, that's just a 5. So when I do this multiplication, the derivative of this function is, excellent, 15e to the 5x. Wonderful. Nicely done. Let's look at problem 3. Do you notice problem 3 is a subtraction problem? So, when I want to take the derivative of this subtraction problem, do I have to look at the whole thing as one unit, or can I look at them separately and take the derivative of each one? Good. You can look at them separately and take the derivative of each one. So to take the derivative of this function, you're going to take the derivative with respect to x, because that's the variable here, of the 4, right? And then minus the derivative with respect of x of e to the 2x. Agreed? Okay. So what's the derivative of 4? Yeah, just 0. The derivative of a constant is just 0. Okay. And now when I take the derivative of this exponential function with the base e, what do I get? Good. You get itself. Is that it? Wonderful. Based upon the last 2 problems, you will be multiplying this by the derivative of the power. So I have to take the derivative of 2x, don't I? Wonderful. So here, well, 0 just drops out, right? So I'm going to get a negative e to the 2x, and you're multiplying it by, good, because the derivative of 2x is just 2. Correct? So, for problem number 3, the derivative of this function is going to be what? Tell me what I write when I multiply this together. Good. Negative 2e to the 2x. With me? Okay, stay tuned. Got a couple more examples for us. So, let's look at problem 4. Still being asked to take the derivative, and now if you notice, I have a product. So, this one is treated differently than addition and subtraction problems, correct? We don't take them individually. This product, if you remember from a previous lecture, is going to turn into an addition problem, correct? Okay, so let's see what you remember. For us to take the derivative of f of x, the first thing we take the derivative of is, good, x to the 7th. So, I'm going to take the derivative of x to the 7th. And you know what? You guys know what the derivative of x to the 7th is, so let's just write that down. What is that? Good, I heard you. The derivative of x to the 7th is 7x to the power of 6. And you're going to multiply it by, good, e to the power of 4x. And now we add to it. What do we add to it? Good, x to the 7th. And then you got to multiply it by the second function, don't you? So now I need the derivative of e to the 4x. Good, I heard you. You're like, well, that's e to the 4x. That's true. But then, oh yeah, we got to multiply this thing by the derivative of the power. Right? All right. So, this is 7x to the power of 6 times e to the 4x, and we're adding to it, good, x to the power of 7 times e to the 4x times 4, because that's a 4, isn't it? All right, now, we got to try to simplify this thing, don't we? So there's the 7, x to the power of 6, e to the 4x. Adding to it, yeah, I can write the 4 first. Okay, This is a lovely looking problem. Now, if you remember from a previous lecture, sometimes the simplifying is more challenging than actually taking the derivative. Because to simplify this, I could try to add it, but it's not going to add because nothing's the same. So remember what we do is we try to factor out what's in common. So help me out here. Between these two terms, what do you see in common? Good. It's pretty obvious you have an e to the 4x in common. Agreed? But is there anything else in common? Yeah, you have x's in common, don't you? There's 6 of them here and 7 there. So how many are in common? Yeah, you've got 6 of them in common. So let's see what's left over when you take those 6 x's out. So in this first one, that's right, the 7 remains. You're taking out an x to the 6, so there's no x's. Take an e to the 4x out, none of those left. So in this first term, all you're left with is a 7, aren't you? So be it. Plus, let's look at the second one. Yeah, the 4 is definitely left. Okay, I've got 7 x's here, and you're taking 6 of them out. Good, one of them's left. E to the 4x is coming out, and so that looks like it. And can I add the 7 and the 4x? Nope. So there's your final answer. Good? All right. Let's look at problem 5. Yeah, problem 5 is a quotient problem, isn't it? So on a quotient problem, that turns to subtraction. Agreed? All right, so let's see what you remember here. To take the derivative of g of x, what's the first thing I do? Good, take the derivative of the numerator. So I'm going to just write it down here so I have a little bit more room. That's e to 3x. Just e to the 3x? Ah, times the derivative of the power, which is 3. Correct? Remember, the derivative of this numerator is itself times the derivative of the power. And then you're going to multiply this by the denominator. All right. And then what? Good, we subtract. And then we write the numerator. And what do? Good, multiply it by the derivative of the denominator. So what's the derivative of that denominator? 6x to the power of 5. Excellent, good job. Is that it? Ah, yeah, the denominator. The denominator is going to end up being squared. Lovely. All right. So let's see what this is looking like. All right. Let's simplify this first one. And simplifying that first one is basically just kind of rearranging the order, because I can't really multiply these 3 guys together. So we write down what we want to do. Okay with that? All right. Minus, let's look at the second part. Yep, same thing. Not really able to multiply anything together, but I'm at least going to write down what I want to do. All over. So what's x to the power of 6 squared? Remember, what do you do between the two exponents when they're through parentheses? Good, multiply them. You get x to the 12th. Remember, you do 2 times 6 because the parentheses tell you to multiply these two numbers together. All right? All right. Now, can I subtract the numerator? Are they the same? Yeah, no. Well, that's a bummer. All right, so what are we going to do? That's it. Factor! All right, here we go. Like I said, sometimes simplifying it is more challenging than actually taking its derivative. So I'm going to continue it over here. Why? Because I got a little more room. What's in common between these two terms in the numerator? Good. We have a 3 in common for sure, right? Because the 3 and the 6. X's. Yeah, how many x's are in common? Good. 6 of them here, 5 of them there. How many? 5. I can only take 5 out of each one because this guy doesn't have any more than 5 to give. What about Yeah, they both have an e to the 3x, so I'm taking that out also. All right, so let's see what's left. So on this first term, you took out the 3. You took out 5 x's. How many are left? Just 1. You took out the e to the 3x. See ya. All right, on the second one, you took out the 3. Good, so what's 6 divided by 3? 2. Awesome, because remember, you're factoring. Those 5 x's are gone. That e to the 3x is gone. And it's still over, it's still over x to the power of 12. Excellent. All right. Well, I can't do x minus 2, so that's going to stay the same. But this is a fraction. And what do you do with a fraction if possible? Yeah, you reduce it. So there's my question to you. Are you able to reduce this? Some of you aren't sure. Well, gratefully, this is 3 times that x to the 5th times the e to the 3x times the parenthesis. So since that's all multiplication, I can kind of look at them separately and see if there's anything to cancel, right? Good. I have 12 x's down here and 5 up here. So these guys will cancel, won't they? And how many x's are left? Good. 7 of them. Where? On the bottom. I have an x to the 7th left on the bottom, which tells me the derivative of this function is going to be 3e to the 3x times the parentheses of x minus 2 all over x to the power of 7. Good job. And this would be my final answer. Y'all with me there? Okay, getting the hang of taking the derivative of e to the power of whatever. Remember, it's itself times the derivative of the power. And gratefully, we know how to take the derivative of just about everything now. 3x or x squared plus 8 or whatever. Good? Hang in there. Got a couple more examples. So let's look at problem number 6. Still asking us to take the derivative. And if you notice, this is an exponential function with the base e. So to take the derivative of an exponential function to the base e, what are you going to do? Yeah, you're like, well, that's just itself. Absolutely correct. That's just itself. Is that it? Oh, yeah, that's right. You got to take the derivative of the power. All right. You guys know what the derivative of negative x squared plus 8x is. It's an addition problem. So that makes it a little easy for us, doesn't it? Or easier, I should say. So, and as a matter of fact, let me kind of do this. Just for some of you who are visual, you're like, could you? I heard ya. Okay, so you are going to multiply this by the derivative of the power. Just a little reinforcement. All right. So, this is going to be e to the negative x squared plus 8x. All right, so what's the derivative of negative x squared? Good, negative 2x. What's the derivative of 8x? Good, 8. So that means the derivative of this function is, we're going to write the negative 2x plus 8 first. Why? Aesthetically, it looks nicer. Multiplied by e to the negative x squared plus 8x. Awesome. You all right with it? Cool. All right, let's look at number 7. Number 7 looks like another product, doesn't it? All right, so let's get our product hat on, so to speak. And I've got to take the derivative of this function. So, what do I take the derivative of first? Yeah, what's in parentheses? So what's the derivative of what's in parentheses? 2x plus 3. Good. And then what? Multiply by e to the x. Awesome. Then what? Yes, an addition problem. What are you adding to it? Good. What's in parentheses, right? because I don't touch that now. And then what? Multiply by the derivative of e to the x, which is just e to the x, right? Good. Well, this doesn't look so bad, does it? You're like, wait, what about the power? You're right. Then you got to take this and multiply by the derivative of the power. So you have to multiply by the derivative of x, which is just what? Yeah, that's just a 1, isn't it? Okay, just checking. So it looks like we have 2x plus 3 times e to the x, plus we have this lovely parenthesis, times e to the x times 1. So nothing's changing there, correct? Okay, now what? Simplify. Yes. And factor out. What can I factor out? Yeah, we can factor out that e to the x. So I'm going to have 2x plus 3, and I'm adding to it this second degree polynomial. All right. Well, clearly there are things that I can combine in these brackets now. We'll have an x squared. We'll have a 5x. And it looks like we have what? Plus 6? Right? You with me? Okay. Well, you know, interestingly enough, that would probably factor, wouldn't it? But did they ask me to factor? No. So leave it alone. I know I could factor that bracket still, but they didn't ask me to factor. They asked me to take the derivative. So I did. I found the derivative of the function. It's e to the x times that second degree polynomial. That's it. They didn't ask me to factor. I ain't going to do it. You're like, yeah, but the only time I do it is to simplify. If I factor that, I'm not really simplifying anything. So understand the difference of when you're factoring. I'm factoring the e to the x out to see if I can add what's left. And in this case, I could. With me? All right, hang in there. Got a couple more. So, problem number 8. Still asking me to take the derivative, right? You're like, there's a square root. Yeah, I'm not liking that too much either. Are you? So remember how you rewrite a square root as a power, as an exponent? Good. I can actually rewrite this as e to the x minus 1, the quantity to the power of 1/2. Yay! All right. So, how do I take the derivative of that? Yes, this is a power. I have a 1/2 power, which means you bring down the power, you reduce the power by 1. So what's 1/2 minus 1? Staff the calculator. Good. Negative 1/2. And then, are we done? Yeah, no. That extended power rule says you've got to multiply this by the derivative of that base. Don't you? Okay. So, we have 1/2 in parentheses e to the x minus 1 to the negative 1/2 power multiplied by, yeah, gratefully I'm just multiplying by e to the x, aren't I? Because the derivative of e to the x is e to the x, and since it's a subtraction problem, I'm going to look at it separately from the 1, and the derivative of 1 is 0. Loving it. All right, so let's see what this is looking like. So, I don't know about you, but, so I've got the 1/2, right? But I've got this parenthesis to a negative exponent. So where does it belong? It belongs in the denominator. E to the x minus 1 to the positive 1/2 power. And what about that e to the x? Good, it stays on the top. So, the derivative in this case is e to the x over 2 times that square root of e to the x minus 1. Because remember, 1/2 power is a root. So I'm just going to rewrite it. You all right with it? Lovely. All right, let's look at this thing. Another product rule, isn't it? All right, so be careful when you do this because these guys aren't bad. You know, sometimes they just try to make them a little more involved, but still, we know how to take the derivative of a product. What do we do first? Take the derivative of the parenthesis, right? Because there's the multiplication. So what's the derivative of my parenthesis? Good, that'll be 10x minus 8. Good job. Then what? Yeah, multiply it by the second one. We leave the second one alone. And then add. Good. What are we adding? Yeah, we leave the first one alone now, so that's 5x squared minus 8x. Then what? Oh, I get to take the derivative of e. Yay, which is, yep, just itself. But, oh yeah, gotta take the derivative of its power. Yep, I have to take it. I'm going to try to squeeze it in here. X squared minus 4x. Right? All right. So let's see what we got. So the derivative of this is, we just am rewriting. I'm not really doing a whole lot with it at this point. Why? Because I've got to figure out what the derivative is of this latter part. So what's the derivative of x squared minus 4x? Good. 2x minus 4. Awesome! Okay. I don't know about you, but there's a lot going on up here. And I don't know what I can add together, but I see I can certainly factor out the what. Yeah, we can at least factor out this e to the x squared minus 4x, right? All right, so let's take that out. Like I said, sometimes the simplifying is more challenging than the actual derivative part. But it's okay. We can handle it. Why? Because we know how to factor. So this is what I'm taking out, because that's in common. When I do that, from the first one, yeah, we have the 10x minus 8 plus. From the second one, good, we have this parenthesis of 5x squared minus 8x times the 2x minus 4. Awesome. All right. Now what? Yeah, simplify what's in brackets, right? So how do you simplify what's in the brackets? What do you got to do first? Good, you actually have to multiply these two guys together first, don't you? All right. Wow. This problem isn't just testing your knowledge on how to take the derivative. It's also testing your knowledge on factoring. It's also testing your knowledge on how do you multiply polynomials, right? Okay, so the 10x minus 8 plus. So I'm assuming you remember how to do this. So why don't you just pause the video, go multiply these guys together, and then come back and see if we agree. Go ahead, I'll wait. You're back. Got it? Okay. So I'm getting 10x cubed minus 20x squared minus 16x squared plus 32x. Do you agree? All right, so still in the brackets. Let's combine like terms. This e to the power of x squared minus 4x, we're still writing it down. There's not much we can do with it. And let's see. I have an x cubed. Well, not much I can do with the x cubed, so I'm just going to write 10x cubed. I got a couple of x squares, don't I? Okay, so what are you going to get? I heard you. Minus 36x squared. All right. And then I've got a 10x and a positive 32x. Good. Positive 42x. And then that minus 8. Okay. Anything else we can do? Yeah, not much. Can't add anything more in the brackets. I'm not going to factor the brackets because if I factor it, I don't know what it's going to do for me. Right? Okay, so do you think you're done? Yeah, you are. Good job. So, what do you think? All right, so far so good. You just when they give you these products and these quotients and these square roots, you're like, I know how to do it. I just have to be careful. You're right. You just have to be careful. So stay tuned. I actually have a couple of stories for us. I'll be right back.